All right, I just want to explain some things, some practical things with angle of elevation and angle of depression to help you get a better handle on some of those trig application problems we had a worksheet on, okay? So basically, angle of elevation is looking up, and it's the angle relative to the horizon. Now, so the person on the ground here spots the balloon. She's looking up. Her line of sight is making an angle of 38 degrees with the horizon. That's called the angle of elevation, okay? The person in the balloon is looking down. Their angle is measured relative to the horizon up here, and they're looking down with the same angle with the horizon and the line of sight of 38 degrees. So angle of depression is from the horizon looking down, angle of elevation from the horizon looking up, okay? Another application here. Person on the mountain sees the peak over here, is looking up, measuring relative to an imaginary horizon line here, looking up with the angle of elevation, looking down at the cabin with an angle of depression. Person in the cabin looking up has an angle of elevation. So let's look at a couple problems, okay? Let's look at this example problem 2 here. Surveying. Okay, the surveyor uses an instrument over here on a tripod called a transom. Okay, there it is. Okay, there's the transom over there. Now, it says that what they are doing is they're trying to get an idea as to the height of this rock. Okay, this arch. Okay, so now, never mind the fact that the instrument stands 5 feet tall unto itself. We'll take that in the calculations later. But, okay, what we can see says that he stands 36 feet away from the rock, and his instruments are telling him that he's spotting through his instrument the peak of the rock here at an angle of 48 degrees. So we want to know the elevation x here. So looks like a tangent problem. The tangent of 48, x over this distance height, tangent of course opposite over adjacent, x over 36. We do our calculations. We find that x is 39.98. We're going to call it 40. However, remember, the tripod itself is 5 feet off of the ground. So this arch is 40 feet above the tripod height, but total of 45 feet. Okay? So hopefully that will allow you to understand that a little bit. Here's an airplane coming in. Okay? So the airplane is beginning to make its descent, okay? And they figure that they have to make a descent at an angle of 3 degrees, okay? And that they're coming in from an altitude of 2,700 feet, okay? And spots the airport 1,007 feet away, okay? How many miles from the runway is the airplane when it starts its descent, okay? So here's what we're looking at, okay? Here's the angle looking down. Here's the elevation of the plane, okay? And the altitude of the airport is at 1,007 feet, okay? So actually, he's not dropping this distance because the airport is 1,000 feet tall. He's dropping the difference between here, which is 1,700 feet, okay? The angle of descent or the angle of depression looking down is the same as the angle over here looking up, okay? So this 3 degrees is 3 degrees down here. What we're after is, okay, this horizontal distance. Looks like we're going to use a sine ratio here. It looks like we're looking for the value of x, which is the hypotenuse here. So we're going to use the sine value here, okay? Work it out, okay? They're asking to find a value in feet, I mean in miles, so we have to use the conversion, 5,280 feet to a mile, okay? So when we're working this out, we find that the x value is 32,616, but then That is divided by 5,280 feet per mile to say that he's going to have travel along this hypotenuse path of 6 miles, okay? So we can come back with another video, maybe do another example or two, okay?